Hey everybody, in this short video I thought we'll take a look at creating some sinusoidal shapes. One example is shown here in the screen. So how do you draw things like this using processing? I'm using the Python variant of processing, and to make things just a little more complicated I'm going to add animation to it. Okay, so the setup is nothing special. We're just going to create a canvas of 500 by 500, and then I'm going to draw the curve using blue as the color. My base radius is going to be 100. I will not change this for this entire video, but because we wanted to do animation, I thought we'll use in each frame I'm going to increase my angle by 1 degree, right? So if there's going to be a number of steps is 360 to complete one full circle. My angular step, which is in radians, is going to be 2 pi divided by the number of steps, 2 pi divided by 360. So how do we put this together? In order to have the animation to work, the idea is that in each frame I'm going to draw a little more of the shape. Okay, I do that by increasing what I call my max angle. But remember, since I have to draw a partial shape, I have to draw everything starting from 0 to the max angle. In the case of a circle, it will look like this. Let's say that we are drawing a circle and we reached the 90th frame. Then I want to draw a quarter circle. Okay. Then 90 more frames later, I would have finished 180, and then my max angle would be 180 or pi, and then it will become 3 by 4 pi, 270 degrees, and then it will become 2 pi itself. Right? Now, once I reach 2 pi, I want my angle to become 0. It gets reset so that we can continue. And for that, we use this modulus operator in Python. So you remember that our max steps is, let's say, 360. So we use this trick here. I'll say that my max angle is frame count modulus max step, right? So when frame count starts from 0, 1, 2, it's just itself. But as soon as frame count crosses 360 or hits 360, it will get reset to 0, and then it will keep increasing. Frame count is increasing infinitely, right, forever. But my max angle will always stay between 0 and 360 because it is the modulus operator. Now, here is how you draw, taking all this. In any given frame, I say that for my index going from 0 to max angle, using my blue marker, which is the stroke 00250, I'm going to say that my angle is my current index value times the angular step, and then I draw a partial angle here. This will become very clear if we look at, for example, how to draw a shape. Let's say that you want to draw a simple circle, but instead of drawing it all at once, I want to increase the circle a little bit in each frame. So I would say that my angle A is idx times angular step, and then I can do r cos A and r sin A. We know that r is 100, so it will draw a point of blue color, so it's slowly increasing. Now let's go to processing and take a look at how this happens. Okay, let's look at actual code now. So in my setup, I set up the size and the blue pen stroke. And here are some variables that are available to all functions. My num steps is 360 because I want 1 degree change in each frame. Then I get a step in radians, that is 2 pi divided by 360. And my radius for all circles or any ellipsoid that any sinusoid that I draw is 100. In draw, here is what I'm doing. I'm creating a white background without any fill, stroke size, and all that. Translate is important, right? I take my coordinate system to be the center of the canvas, width by 2, height by 2. Using a green color, stroke 0240, I'm drawing one ellipse, which is just to anchor us. And then I switch the color back to blue so that I can start drawing my partial sinusoid shape each time. This we already looked at. Max angle is frame count modulus 360. Okay, so max angle will go start from 0, keep going up to 360, and then once frame count starts going over 360, it will get reset to 0 and keep going. It will stay between 0 to 360. My partial shape I'm going to draw here. Angle in range of max angle, meaning from 0 till max angle. Let's say max angle was 270, so I'm going to draw from 0 to 270, convert it to radians, take the angle and multiply it by step, which we saw here is simply in radians. And then I'm going to calculate the x, which is r cos theta, y cos theta, and then I'm going to draw it. One more.
and it gets reset.
Okay, now that we know how to draw an animated circle with slowly increasing max angle, let's try to make some variants. One very simple thing we can do is to start trying to change the circle, but before that, here is a trick that I picked up. Instead of drawing a point which shows up as 1 pixel by 1 pixel, sometimes difficult to see, just to exaggerate the effect a little bit, I draw a very tiny circle. In this case, I call it an ellipse, but it's actually a very tiny circle at the same place, x, y, of size, width and height is the same, so it's a circle. Okay. With that change, I want to go back to our code and make this one small change. I'll show it in code, but I first want us to understand what is going on. In this case, we are saying that x is equal to r cos a times 2. Okay, so what used to be x has now become 2x, twice that. So in order, it goes from minus r to plus r, x used to go, now it goes from minus 2r to plus 2r. Making that has the effect of squishing the circle a little bit, or rather stretching it out, and it creates the horizontally lined ellipse, if you will, right? If you could do this to cos, certainly you can try it to sine as well. And so in this case, we're going to make sine go from minus 2r to plus 2r, which creates this vertically stretched ellipse. Now let's go and take a look at code to see how to make that happen. Let's make one simple change, right? So we're going to say that y is r into sine theta, sine of the angle, times 2. Okay, so the y direction we have, let's save this and run it, and I'll explain what I'm hoping to happen. Y gets twice the distance it covers. So y goes from minus 2r to plus 2r, whereas x only in the same time in the distance that x goes from positive r to negative r. Okay, so if you are able to see something on your screen, you see this elongated sort of vertically standing ellipse, right? Because it's squished or elongated on the y-axis, right? It doesn't have to be y, of course. Let me stop this, and I can also just as well try this for, you can squish it on the x direction, squish or elongate, in which case we expect that the x will go from minus r to plus r, minus 2r to plus 2r, so x-axis is much more elongated, and the y is only going from plus r to minus r. So it goes twice as far in the x direction as it goes on the y direction. In other words, it's twice as wide as it is high, the height. Okay. Now that we have learned how to create this, I'm going to make one small change, but it has a very profound impact. So watch carefully. You see how we took y and multiplied it by 2? Instead of multiplying the overall y, I'm just going to multiply only the angle by 2. So watch. Okay, so the code changed. So what was outside, I'm going to take it in 2 star a, 2a, and look at that impact, right? So in this case, because the sine angle moves at twice the rate of cos, it is actually able to finish 2 revolutions for every 1 full revolution of that x can perform. So even though in the x direction you went only once, if you notice here, this will probably start from here. So the y finishes 1 loop and then goes and finishes a second one. Okay, so that's what it would happen. And if you can do something for y, you can certainly do it for x as well. So this goes, makes this parabola effect. So whenever it's even number, it seems to leave it open. Now you got the idea, right? How to create any number of sinusoidal curves. Since we can do it for 2, you can do it for any random n. And so here are a few images that I created. We'll take a look at the code as well. So in this case, I think this was probably where n is equal to 3, maybe it's 4, 5, and so on. We can try it for different odd and even numbered n, it behaves differently. And what you can do with n, so to totally generalize this, we can say that cos of n star a and sine of m star a. So I've just shown you. So this is what I mean by n is 3 and m is 2, and it creates this image. We can keep changing it and it will look different. So let's take a quick look at that, and with that we'll try to end the video. Okay. We can do, instead of multiplying the whole of the y, we just want only our angle to be multiplied. So notice what I did. Okay. So just the part that said sine angle, I've made the sine angle multiplied it by 3. Okay, so you should think in terms of angles. By the time the x direction, this has made a one full circle. The y direction, it makes it 3 times. Okay, so 1, 2, I guess that's 2 and 3. That's 1, that's 2 and 3. Okay, so you got an idea, right? Whatever we can do for x, we can do. Why don't we just simply generalize, and then we say m and n. So let me say that n star 3, and this is going to be m star a. This should be n star a. And we can say that my m is equal to, let's say, 3, n is equal to 2. When you run this, right, now in the time that it takes the y direction completes 2 full circle or cycle, x-axis has done 3. Okay, so this is what leads to an interesting shape. So if you're able to follow it along, it forms this, if it's showing up on your screen there. So if you notice carefully, on the x direction, it's going 3 times. That's 1, that's 2, and that's 3, and at the same time it does it 1. Just by playing around, I found that odd numbers for x or for cosine seems to give different interesting shapes. So now this is where I'll stop. So the last thing I want to show is, what if we made m is equal to 7 and n is 2? So of course you can see that it's looking more jagged or dotty now because it's gonna spread, but there is a sinusoidal almost goes over a cylinder, so you can see that the x has to do a lot of work here, where it goes 7 times in the same time. Y-axis has to be covered just twice. Okay, so you can play around with it. I'll make the code available. Thank you for watching, and thank you for your time.